Okay สวัสดีครับ Hi everybody student we continue with our lecture which is the last part for this physical processes the last part is mass transfer. For the mass transfer I will divide it into two parts. The first part is molecular diffusion, diffusion in bioprocesses, film theory, convection, oxygen uptake, and then the last part is the factor that affect the oxygen transfer. We normally know that the microorganism inside the bioprocesses is require oxygen. So let's begin with the diffusion. Diffusion is movement of component under the mixture, and then is concentration difference is driving force for the system. Fixed law is applied for the diffusion. The flux, this is mass flux, is similar to the heat flux here, and diffusibility and the concentration difference, concentration gradient for example. And we can have a look at diffusion of urea, which is a molecule in agar. Agar is the gel tube. It's like a long tube gel solution, which is 1.05 weight percent agar in water at this Kelvin. This is 5 degrees Celsius for example, and have this kind of long 4 centimeter and connect to solution urea in water. The urea has this concentration of the other side, grammole per liter. This is molar for example, and the other end is 0. And we calculate the urea in terms of this one at the steady state, the mass flux. Okay, we have this diffusibility of this 1 square meter per centimeter for urea and agar, and then you have the length of this one, and then we just simple use this calculation. Molar at the other end, and then this is 4 centimeter as I said before, and this is diffusibility, and then you come up with this mass flux, kilogram per mole per cubic centimeter square, meter square, and then second. And the other question is, how can we find this diffusibility? Simple question. The simple answer is, well, we look from the book, and this one is transport processes and separation process principle from the writer here. And then we have the solute, they have the gel, many things, agarose and percent, and we have temperature, and then there is diffusibility, this one, typical solute in biological gel aqueous. And this one is urea and agar, this urea and agar. So you use this one, different gel, and you have look at different. Basically you just find the book and then look at inside. There are many chemical engineering book that you can looking for. And the role of diffusion in bioprocesses are in which diffusion, scale up mixing, turbulence produce bulk mixing. So we want, if we want good mixing, we just introduce turbulence to the system. Eddy size, very small eddy, the one that I mentioned in the fluid. So the very small swirl things inside. And mixing, okay. Mixing is molecular scale, therefore rely on diffusion is a final step in mixing process. Diffusion is the last step, final step. Okay. And solid phase reaction, sometimes by catalyst or the solid forms like clump, fork, film, cell, immobilized cell, for example. Immobilized is you stick the cell in one particle. Transport solid, okay. Mass transfer within solid is usually by convection only mechanism. Diffusion also responsible for removal of products. Okay, you just diffuse. It just have different kind of concentration. In the mass transfer across the phase boundary. Okay, and liquid transfer from a gas bubble to fermentation board, penicillin, aqueous to organic solid. This is the example of this one. Okay, this next section, these are similar to the film theory. This is how diffusion in bioprocesses look like. And we have film theory, use model for mass transfer between two phases. One phase to another phase involve the phase boundary is just the one that they meet each other between the phase. And then we have this one, the organic phase, the aqueous phase. Organic, aqueous is water. This is boundary, phase boundary. They have different kind of solution, different. This is organic film, for example, and then aqueous film. And we have convection, which is use this one, overall mass transfer coefficient. This one. The this is a concentration difference. Okay, diffusion occur. This one is again convection is related to the motion, to the motion of this one, and this one is convection between solid phase. So we have 0 here, see, and then we are increase a bit here. This is a film of the liquid film. This is solid part. The concentration cannot reach this point. And if we have gas and liquid system, this liquid phase, this is gas phase, is a temperature inside. This is film between the two here. So it's just concentration profile from this one to this one. And so the oxygen uptake in the cell culture, if we have a look oxygen transfer from the bubble to the cell, we have this step. Is quite complicated system. First is transfer from interior of the bubble to the gas liquid interface, or we have gas and liquid interface, and from this text is quite complex. And if you have a look on the picture, you have very clear idea. This is the first step. From the gas bubble is we enlarge the system. This is first step. From the gas bubble to the interface. Is the first step. And the second step is moving across the gas and liquid interface. This one, across. Okay. And the third step is diffuse through to the liquid film. Now is from gas and then to the liquid. This is the third step to the liquid film. This is called liquid film. This is interface, and then this liquid film. Transfer to the bulk liquid. The fourth step. Okay, this bulk liquid system. This is a cell crumb, for example. This is individual cell, for example. So it's have sometimes the cell is form aggregate, but sometimes the cell is form just individual cell. Is this is the fourth step from the film of the liquid to the bulk liquid. Is a fourth step. This one, and through is very small film across the cell. This one, film of the cell, film of the individual cell, for example. And moving across cell interface, liquid and cell interface. Number 6, cell, and then number 6 here is, this is very small. And number 7, okay, diffuse to the solid to individual cell. This number 6 is very small already. And 8 and 7 here. This one is doesn't have the 7 step only, because it's individual cell. This one is from clump to individual cell. And the final step is transport to the active side of the reaction. This one, active side of the reaction. Okay, this is how we summary. And if we have a look on how to calculate it, and this is an example, cell concentration is aerobic culture. Aerobic means you use oxygen. Stain of this microorganism, Acetobacter veni is similar to the vinegar or something like. Culture in this stir fermenter for produce the alginate production. Under current operation of this mass transfer coefficient, which is this unit per centimeter per second. Okay, this property of the oxygen solution. Oxygen uptake is this one, maximum possible cell concentration. This is the oxygen uptake by the cell, and then we calculate the maximum cell that we have and maximum concentration now. Okay, if the bacteria, this one, suffer, okay, after you use this kind of compound, and then it's die, for example, so it's reduced from this one to this one, maximum concentration is different. This is cell concentration, mass transfer coefficient, and then this one, this equation, 947. Okay, let me have a look if we have this kind of thing. This is a heat transfer, mass transfer. Okay, have a look on 9.40. Okay, this one, the maximum number. Okay, this is a step, maximum number 940. This one, okay, cell concentration. Okay, is okay, similar things. Again, this is your cell concentration. You just use this equation and then put it in, and then change the unit. And again, if you reduce from this one to this one, and then the maximum cell is a bit lower. Okay, a bit lower than the first one. So achieve calculation cell density of all condition must be favorable. Okay, and you have a look on this equation. And for the last part, factor that affect oxygen transfer, again, is bubble size, bubbles is how you put air inside, and stirrer medium property, antifoam agent, you put the temperature. If the temperature change, the oxygen inside is less barrel, the pressure inside the system. And again, if you have more cell for this one, and you might require more oxygen. For the next part, I will continue on the mass transfer, so how we measure the oxygen concentration, and then these are the topics that will be included in the next section. For this one, the more important thing is this one, the step of the cell the step of oxygen transfer from the gas bubble to the cells. Okay, we will see again next lecture. Okay, for today I just say goodbye.